So we know that 80% of our existence and our health is in our own hands. That's great. That's really my message. And one of the reasons I wrote the book is that don't be afraid of aging. Take action, because you really can have a big impact on your own life. And spread the word, because there's really a lot we can do. Fairly simple things to live longer and healthier. Okay, so this is a picture of a young person and an old person. And when I ask you how long do you want to live, I want you to imagine that some of the technologies that I'm going to talk about tonight and the things you can do will actually work. So here's what I'm trying to get at. If you don't feel any different and you've got a great career and you're surrounded by family and friends, is there a date when you want to die? Is there a point in life where you just get bored? I've seen every movie. I've done everything I want to do. My bucket list is full. I want to die. Bang. Is there a date? Sounds like yes, that's fair. That's totally fine. I was once on a plane with a guy who was flying with me to Tokyo. And I told him that we're working on aging and trying to make people live healthier for longer. And he goes, I don't know, that doesn't sound natural. I said, are you kidding me? We're drinking gin and tonics, we're texting our partners, we're watching movies 10,000 feet above the ground. Don't give me what's natural. So the point is that we can engineer our way out of things that initially most of the gains in average lifespan were at the lower end of life. And most of us can expect to live, if we're lucky enough, to get through our 40s, 50s, and 60s. So we're coming up against the limit, which is aging. Okay, so that, we can study childhood diseases a lot, and I think that's worthy. But most of us now get to be old, and that's the problem, the biggest problem on the planet. So right now, as of last year, there are more people on Earth who are over 65 than under the age of 5. And that's the first time ever in human history. And it's only going to continue to widen. So our problem as a species is, what are we going to do with all the people who are frail and cannot work and have to go to a nursing home? That's a lot of money. We already spend in the US 17% of our GDP taking care mostly of the sick and the elderly. And it's only going to get worse unless we do something about it. So we really have two futures. One is, let's just forget about aging and we'll just deal with a lot of sick people who spend more and more of their percent of their lives being looked after. Or we can say, this is a problem, let's figure it out and let's fix it, which is what we've done for everything. That's why we wear clothes and we're indoors in a heated building. So hopefully I've convinced you, at least you've seen my argument, that it's natural, therefore acceptable. That argument should be thrown out the window. We've never as a species accepted things that have caused us pain or difficulty just because they're natural. All right, so this is the anti-aging. If you go online, you will be completely depressed. And why do I say that? Because you don't know what to believe. People are saying, take this pill, take that pill, this pill works. David Sinclair says so. It's all wrong. I don't say any product works. But this is the world we live in. We have a world of pharmaceuticals which are essentially proven to work, and a world of supplements which are not proven to work. But there's some academics like me that have maybe treated a mouse, so it looks kind of interesting. And what's difficult about the world that I'm in is that I'm trying to do the hardcore research and make medicines, but every day, understandably, I'm asked by people, well, that's great about medicines, but I'm getting old right now. What can I do now? And so I've written the book, which covers both angles. What are the medicines that are in the pipeline? What are the medicines you could get prescribed right now that would slow aging, we think? But also, what can you do in your daily lives that you don't need a doctor to do? I want to bring up antioxidants. So, I hope I don't get sued for saying this, but antioxidants have been extremely disappointing in the aging field. Longevity, not anti-aging field. Why is that? Because there's a lot of things going wrong in the body besides free radical damage. It was a good story. It made some sense, and all fables are built on things that make sense. It doesn't mean they're true. And antioxidants actually have been a large failure in the aging field. And we haven't had a lot of success treating animals with antioxidants and making them live healthier or longer. And even antioxidants are healthy for you. Yep. But antioxidants, unfortunately, not the cure to aging, right? Or we'll all be living to 150 at this point, or at least some of us who are eating a lot of blueberries and drinking Pom Wonderful every day. I'm not saying they're bad for you, but I'm reminding you that we know a lot more, but people don't know about it yet. So this is what scientists believe are the main causes of aging. These are called the hallmarks of aging, and there are 8 or 9 depending on which continent you come from. And some of these you've probably heard of, right? They make it into the public's perception of what we work on. There is, well, let's see, cellular senescence. How many of you have heard of senescence before? A few? Yeah, so what this is that cells will become old and lose their identity, and they'll check out and they'll just sit there. And that would be not so bad if it wasn't for the fact that these senescent cells, or sometimes we call them the zombie cells, they start putting out all these other signals in the cell or outside of the cell that make other cells sick. So even though if you don't have a lot of senescent cells in your body, even if it's only a few percent, they will basically cause the rest of your body to become inflamed and aged as well. And we know that mostly from mouse experiments where you put a few senescent cells, a little dab of senescent cells in the animal, and the whole animal gets old. So they're horrible. So we don't want zombie cells. We don't want to run out of stem cells. DNA damage, genome instability, so that's a picture of DNA we've known about for many years. Telomeres, the ends of chromosomes, get shorter. And, it goes on and on and on. But here's the point. This was 10 years ago, and the field of aging research, we felt pretty good about ourselves. We said, yeah, we figured this out. Put a flag in the ground, we've done this. We figured out what causes aging. And everyone, with very few exception, has started or focused their lab on this one. Or there's a purple lab, and there's a green lab, and there's a red lab. But I've always believed that you can simplify everything. I'm a reductionist. And I think eventually we can reduce aging down to a single equation. And I'll tell you what that is. Aging is essentially what's driving all of these things is a loss of information. Okay? We live in an information age. We know what happens when you lose information. We used to lose emails. We don't anymore, and I'll explain why. But information is key. And when we're born, we have all this great information that we got from our parents, and what we ate, what we absorbed in the womb, and how our mother was eating and feeling. That's information. And what we've discovered in my lab is that over time, what's happening to cause all of those things on that pie chart is just one major thing, and that's the loss of information in the cell. Okay. So what kind of information? I'm glad you asked. I'll tell you. So there are 2 types of information in biology. The one you all know about is DNA, genetic information. It's a great way to store information. In fact, you can get information out of a fossil. I can go to a mummy and see that mummy's DNA. That's a very robust way to store information. It's way better than a compact disc or a hard drive. They wouldn't last thousands of years, would they? So DNA is a great storage information. And the reason it's particularly impressive in terms of the biological system is that it's one of the few things in our body that's digital. And we all know digital is better. It's the reason we converted from analog in the first place. We don't use cassette tapes anymore for a good reason, because analog information sucks. Anyone who's had, is old enough to have cassette tapes or record player, records, knows that you can lose information pretty easily if it's stored in analog. But DNA, it's digital. A, T, C, G, that's a digital code. It's not binary, it's quaternary. So what is it about the body's information that gets lost over time? Turns out we used to think it was the digital information that we lost. Right? How many of you, I'm sure all of you have heard, I won't even ask you, we've all heard that mutations drive aging. We're losing genetic information as we get older. The problem with that is that you can delete a lot of genetic information in animals and they don't age. It's also true that very few mutations can be found in our old bodies. The smoking gun just isn't there. And what happened to the field a few years ago was we had no clue what was driving aging at the fundamental level, because the old idea of free radical damage and mutations was out the window. We had nothing to replace it with. And so what I've proposed in the book and in some recent publications and some that are just about to come out is a radical new theory that the other type of information is what we lose over time. It's the analog information in the body, and that's not very stable at all. So what's the analog information? It's this green stuff. This is the DNA, the digital, and the packaging of the genome is the analog form of information. But we need analog information because the analog system tells the cell which genes to read. And without knowing which genes to read, a cell is basically a tumor at best, or dead. We need to have these structures that say, read this gene, but bundle up all these others so you don't read those genes. If all cells read every gene, a nerve cell wouldn't be a nerve cell and a skin cell wouldn't be a skin cell. You need to be able to tell it, only read those 10% of genes and turn off those others. And what we found during aging is that these structures that control how the DNA is packaged, the analog information, which we call the epigenetic information or epigenome, is what gets screwed up with time. Does that make sense? It certainly made a lot of sense to the people in my lab. But just making sense, as I warned you, isn't proof of anything, right? Most things that make sense are wrong, okay? What do? You have to say, well, if I disrupt the analog information, if I accelerate that process, what should happen? Well, we should get aging. We should accelerate that process. The converse should be true. If I can regain the epigenome, the analog information, we should get younger. And that's what we've been doing for 10 years in my lab. So one of the things that happens on the chromosome that disrupts the cell's identity and the ability to read the genes is a broken chromosome. Okay, wherever you see that flash, the chromosome is being broken. And when you break a chromosome, a cell gets really nervous because it's actually the worst thing you can do to a cell, because if a cell doesn't repair a chromosome, it'll die or it'll become a tumor. You got to fix it, no question. You cannot live with broken chromosomes. So what I showed you in that video, those balls are proteins in the cell that we've discovered when I was over at MIT and now and more recently in my lab. These proteins are what we call longevity enzymes. They're encoded by longevity genes. And when we turn them on, the animal's very healthy, they're great. We have mice that live longer, and we think in our bodies they keep us young. But unfortunately, they have two functions. The first function is really important. It's to maintain the structure of the epigenome, to keep us young. So that's great. When we're young, these proteins are in the right place, they're sitting on the right genes, and so the genes that should be on are on, and the genes that should be off are off. But as I showed you in this video, their other role is that they get distracted by broken DNA. Okay, if you go out in the sun and you get sunburn, you broke a lot of DNA, unfortunately. So these proteins are moving from where they should be in a panic to try and repair the DNA. There's a reason for that. I think that that they're moving because they're telling the cell there's an emergency, you got to fight, you got to survive. But if you keep doing that, as I showed, so this is an acceleration of what I think happens during aging. Let's have a look again. These proteins are perfectly aligned. Then they get distracted by the break. They go back to where they came from. They go to the break. They go back to where they came from. They go to the break. Whoops, didn't go back. Whoops, didn't go back. So this is aging, I believe. And we can test this. We can create this in the lab, in an animal, and ask what happens. And we've done that. It's taken us 10 years.